Welcome to ClickMyProject.com. Now we are going to discuss about detecting disorders of consciousness in brain injuries from EEG connectivity through machine learning. Next, overview of the project, that is abstract. The computational electroencephalogram EEG is recently garnering significant attention in examining whether the EEG features can be used as new predictors for the prediction of recovery in moderate brain injury detection. To address this issue, a computer-aided approach is proposed in the article for automated DOC, disorder of consciousness detection through extracting knowledge from electroencephalogram EEG signals. It introduces a new connectivity measure, power spectral density difference, incorporating with the recursive cosine function the subsequent processing steps. As a result, it is crucial to devise a strategy for meticulously flagging and extracting clean EEG data to retrieve high quality discriminative features using PCA for future extraction. Then the approach classifies brain injured patients into DOC, positive, negative, neutral classes through an ensemble machine learning algorithm. Our proposed approach to implement deep learning algorithm RNN for high accuracy prediction status. Okay, detecting brain injury detection using EEG features, that is brain EEG data sets. So EEG dataset measured using PSDD and CPSDD functions. Next, dataset is collected. Okay, this is our project flow diagram. Start, select and load dataset, pre-processing, future extraction, data splitting, classification, and then prediction. First, start our program. Next, select and load brain EEG future data set. Next, pre-processing. Pre-processing is clean the data set. Next, checking null values. If you have any null values, replace with 0 values. Next, any unwanted column or there, removing this process. Next, future extraction. Future extraction is if you have a data set with 30 columns, we want only 20 columns. So using future extraction PCA algorithm, get only 20 futures. Next, data splitting. Our data is splitted into training and testing data. Next, classification. Classification is algorithm implementation. This is KNN and RNN algorithm. KNN is machine learning, K nearer neighbor algorithm. RNN is recurrent neural network algorithm. This is our proposed algorithm. And then prediction. Prediction is like if you have any given EEG features, that is brain injury detection, brain injury detection, or not brain injury detection, mild brain injury detection, given the accurate result, and then performance analysis and report generation. Okay, next, output explanation. This is our output. First, data set, select and load data set. This is our brain injury detection data set. Okay, next process, data pre-processing. Data pre-processing is data cleaning, checking the null values and remove unwanted column. No null values and no unwanted column are there. So going to next process, data splitting. our whole data is splitted into X label dataset and Y label dataset. That's purpose is splitting into target values. Next, future extraction. Future extraction is our data set future is extracted. Reduced number of futures. Okay, next, data splitting. This data splitting is our data is splitted into training and testing data. Okay, this is our future extraction result. Original number of futures 989, reduced number of training futures 15, reduced number of tested futures 15. Next, algorithm implementation. ML, machine learning algorithm, KNN. KNN accuracy is 83. Next, RNN. RNN is our proposed deep learning algorithm. Okay, Approach. Approach is how many times train the process. That is 100. So 100 times trained. RNN accuracy is 87. This is our proposed algorithm. Give high accuracy. Classification report. Precision, recall, FN score and support. Next, confusion matrix. Okay, 3x3 confusion matrix. That's reason is our label values 3, 0, 1, 2. That is 0, 1, 2. So 3x3. This depend upon true positive, false negative values. Next, comparison graph. KNN 83, RNN 86. Prediction status. Prediction status is given data is brain injury or not, mild brain injury. This is our prediction status.